Now, we've got a task class. This can wrap a generator for us, and it can step through each iteration of that generator to do some kind of work. Let's make the class to manage these tasks. I'll call it scheduler. I'll just sit down here. Is that better? Okay, scheduler. Now, just as we needed a place to store the generator in our task class, perhaps it would be good to have a place to store the list of tasks that we want our scheduler to do. I won't do a constructor here, though it's a fairly valid thing that you could do in the scheduler. But what we want to do now is we want to have a way to add a new task to the scheduler. And at this point, we've got to think, what is a sensible way to store and to retrieve these tasks? We want each unit of work to be done in each successive task in a predictable way. If we add task 1 first and we add task 2 second, it should interpolate the units of work for each of those tasks. So some work from task 1, some work from task 2, some work from task 1. So we need to add items to this list of tasks. Say we add them at the end, we need to pull them off the front and add them back to the end if there's still more work to be done, so that each task moves a step to the right, or the left, I guess, and so that tasks are executed in a predictable order. We can do something like this. Again, I'm not going to type into this for reasons that will become clear later on, but we can use array push. This will put the task on the end of the array. So when we get it off, we're just going to have to use array shift. Then we need a way of telling the scheduler to run all the tasks that have been added to it. We can add tasks to this, and we've got an implementation for tasks, but how do we get all the tasks to run till completion? Let's make a function called run, just to be consistent with our task class. Run. So what are we going to do here? Well, while there are still tasks to do, we want to process tasks. That kind of goes without saying. But I said it, so I guess it doesn't go without saying. While there are still tasks to do, we want to process tasks. For each cycle, we'll get a task off the front of the tasks array. We'll do a unit of work with it. And if there is still more work to be done, we'll put it back to the end of the list of tasks. Something like this. Remember, the run function is what we do to get that functionality in the task. And if the task is still valid, in other words, if it still has more work to be done, we use the add task method. That means it will be pushed onto the back. So we're taking a task off the front, we're adding tasks to the back of the list, so they go on and come off in a predictable order. And we can interpolate predictably. How would we use this? Well, we'd create some tasks. And remember, the tasks take in a generator, so we'll have to create a function that has the yield keyword, and we'll have to invoke that function to get an instance of the generator. Because by default, just having a function with the yield keyword is a generator factory. You can think of it like that. You have to invoke that function that has the yield keyword to get an instance of a generator. So we'll use call userfunc for this. This is an interesting way to do immediately executed anonymous functions. And for now, I just want to do something simple so that we can see units of work being done. We'll see more complex examples of using generators to do non-iterable work. But for now, I want to do something simple. So I'll say for each. The range function gives an array of items from minimum to maximum. And for everything here, we'll just print out what this is. Now remember, again, we need to use the yield keyword to make this a generator, but we're not really interested in returning specific data from this. We'll just put a yield here so that it makes it a generator. Okay. And I want to duplicate this so that you can see that multiple tasks can be run with this approach. And because we have something else we want to do as well. Some more changes after this. I'll change the amount of work that has to be done in the second task. Again, so we can see how it interleaves this stuff. And then to use these, we need to make an instance of the scheduler. We can use our add task method. And finally, we have to run this. Okay. Don't remove the trailing lines. What does this look like when we run it? We're probably going to see an error. I don't know. No! Yeah! Cool. Okay. We're almost at the end of this example, and so far it's been okay. Are there any questions so far? Okay. Anything anyone wants me to repeat about the structure of scheduler and task?
Can I ask why it just says task 1 twice at the first?
That is a very good question, and that's what I was going to carry on with.
Okay, carry on.
Okay. So we have this problem that has been deftly spotted. We have task 1 tick 1, task 1 tick 2. The same thing with task 2, and only then it starts doing the interpolation. Of course, task 2 only has 5 ticks, so we expect after task 2's 5th tick to only do ticks from task 1, tick 6 through 10. But this is a problem. It's one of a handful of problems we're going to fix in this code. Who can guess why it's doing this?
Because you call user func when you called the task constructor, so it ran once, then ran again the first time. Scheduler pulled a task off.
Yes, that's good. Can you rephrase that in the context of what this class is doing? Sorry, just to repeat for anyone who didn't hear. What's your name? Ryan has suggested it's because we call this, and so an instance of this is generated, a tick of it is already run. So what we're doing is we're getting 2 ticks run at the same time. Can you rephrase that problem in terms of how this class is created?
I'm not sure.
Can anyone else suggest why that problem exists based on the code in this task class?
Your function's being executed before it's ever passed into task.
Yes, but there's something in this code that I'm interested in that we can change to account for that. Think about the iterator interface that we looked at earlier. What were the functions that we had on there?
Reset?
We had rewind. Rewind is the thing you're thinking of. We had 5 methods there. Current, key, next, rewind, and valid. In this case, what we're doing is we're saying, every time this is run, get next. But the first time it's run, we already have done a unit of work. The pointer is already at 0 inside the generator. We've already done a unit of work. We're just saying next every time. So the first time this is run, current is executed, and next is executed. That's why we have 2 cycles going on. We can get around this by having some kind of check to see whether this has been run already, and if not, we can use current. Else we can use next. Let's see what this does. Way, that looks good. That looks good. So, well spotted for figuring out why it's doing that. And we fixed that problem. That's really cool. Now let's make this code a little easier to use. Look how we're doing these immediately executed function calls. What if we assume that tasks can be created with a function or a generator, because we assume that the function makes a generator? What if we try and code it so that we can do this? That would look a little easier, wouldn't it? Let's leave both of these in here just to make sure that both work. To do that, we need to go to where we create a task. And here say, well, this could be a generator, this could be a function, if it's a function, let's pretend it is a function that will make a generator. We can do it with some code like this. That's not too tricky. Of course, if you were using this kind of thing in production code, you'd probably want to have more checks to make sure that an invocation of this function creates a generator, or that this thing is callable to begin with. But I don't want to do that kind of protection here. I just want to bring across this idea that we can code for generators, or we can work out whether a function is a generator, so that we can create APIs that are easier to use because either thing can be passed in. It means more work on our end when we're creating the APIs for this, because we have to do those security checks. But it's easier to use for someone who's consuming our code. Someone who's consuming this kind of code won't actually dig in here if it's working as expected. They're more interested with this. So we make this easier for them. Does this run? Yes, it does. Does what we want it to do. Okay.
How would you check? I just said you couldn't do this, but how would you check if you had a function after you confirmed it was callable? How would you check? Oh, does this callable yield a generator?
Perhaps you would do something. That's a good question. So, how would you check that this parameter can make a generator? Is I think what the question is. Okay. So you could do something like this. Maybe something like that. It's not actually that much extra code I should probably have done to begin with. But thank you for asking the question. I mean, I think this will work. I should run it to check. But yeah, I think that's fairly safe. So what we've done is we've reduced the need to have an executed function here. It could just be a function that makes a generator. Or it could be a generator. But do we even need this step? Does it matter that this is a task? As long as we can get to a state where our application is happy with the generator that it has or the task that it has, maybe we don't even require this step. Maybe we could do something like this. That seems easier to use than having to make a task as well. We can leave the previous behavior in there, because maybe that works. But then what we can do is we can take this exact same code that we've got here and change it slightly in our add task function. That doesn't make sense. Not instance of generator. Okay, and then task is new task. Not instance of task or generator factory. That made sense. Okay, now we've taken the same utility code that we had in task and we've changed it slightly. If someone's trying to add a task, they can add an instance of task, or they can add a function that makes a generator. And if that function doesn't make a generator, well, we can make a big fuss about it. But if it does make a generator, that's really easy for us. We can just pass that into task. If you weren't doing this validator, you could pass the function directly into new task, and you could do the validation there if you wanted to. But it doesn't do any harm having it here. Does this work? It totally does. Task 1, 2, 3, task 1, 2, 3. How many lines of code have we done here? 97 lines of code, with some white space and 0 doc comments. Maybe you want doc comments to explain what this is doing. But in less than 100 lines of code, we have taken a keyword in PHP, I'll put this back down here, Thank you for the space.
Yep.
We've taken a keyword in